Hi Year 8s. This is the last part to Chapter 4. So we're looking at exercise 4G, which is factorising expressions. This is in fact the opposite to expanding, which is what we did in exercise 4F. So hopefully you can see the relationship between the two processes. All right, so let's have a look at this rule here, or an example of a rule, and what I just stated before, that we're doing the opposite to expanding. So in exercise 4F, we had questions that look like this with a set of brackets, and then we did our distributive law and we ended up with an answer that may have looked something like this, okay, so without the bracket. Now what we're going to be doing is we're going to be given the question like this, and we're going to work backwards and get my laser so you can see what I'm doing. Okay, so we're going to be given this type of expression and we're going to be working backwards to get the brackets back. Okay, that also involves finding highest common factor, okay, and then writing in the brackets what's left over. So here we're just showing you a little bit more process. Okay, I've mentioned finding the highest common factor. So it might just be finding the highest common factor of a number. It might be finding the highest common factor of any of the pronumerals, the letters, or both in the one question. Okay, when you find that highest common factor, this sentence here, we say that we write it in front of the bracket. Okay, so that is the number or the pronumeral or both get written in the front. So for example, if we come back to this 4 is the highest common factor of 12 and 8. Okay, so that's why we write it out the front. And then we put the other factors that are left over in the brackets. So if I've taken a 4 out the front and I want my answer to get back to 12a, I would have needed to multiply this 4 by 3a. 4 3s are 12, and then I need that a as well. And then the same thing here with the 8. If I know that 8 has a common factor of 4, when I look at 8 and 12 together, then what do I need to multiply by 4 to get back to 8? I'd have to multiply it by 2. Okay, so that's the factorising process. This here just shows you similar, okay, more specifically this part here, okay, you are given this expression, they both share a in common, so that a is written out the front, and then you have this b and c left over, which they put in the brackets. Okay, let's see if we can do this with some more questions. So this just simply asks you only to find the highest common factor of each of these terms. So we're not factorising, we're just finding the HCF value, okay, or term. So we've got 3D and 15. We think about the numbers, 3 and 15. We know that they both share a highest common factor of 3. Now what they've done here is they've shown you in a way, instead of just thinking about it in your head, they've shown you in expanded form. So they've written 3D as 3 times D, and they've written 15 as 3 times 5. They both share the 3. So if you find this step here helpful, then write this step out. Okay, and then where they share the same value or pronumeral or both, then you write it out. Okay. Question B, we've got some more things involved here. So we've got a 10FG and a negative 5GH. If you want to write both of them out in expanded form, so this would be 2 times 5 times F times G, and this would be negative 5 times G times H. They share, okay, or in fact they've even done an extra step here and they've put in this negative 1. You don't have to do that, okay? It's not going to change, it's not going to help you find the highest common factor. So if we look at the numbers, they share a 5. The letters, they share the letter G. So the highest common factors are 5 and G. Now this here is negative, and this term here is positive. Now, because this is a positive term, we just simply take the positive 5 as being the common factor and not the negative. Okay, so that's probably why they've written this step out here, and they put the negative here with the 1 when they've split up the 5. So as our final answer, 5G together is the highest common factor of those two terms. Part 2 of this is factorising, okay, using the process that we just did before, finding the highest common factors. We're now going to actually factorise our expressions. So let's have a look at factorising 8x plus 28. 8 and 28, just as the numbers, have a highest common factor of 4. Okay, you need to make sure that you are well equipped with your times tables, okay, when you are trying to find your highest common factors. It is so important when you're doing this. It makes these questions much easier to do if you know your times tables well. So, now that we know that the highest common factor is 4, we can now start to split up each of these terms into their multiplications using the number 4. So 8x can be rewritten as 4 times 2x, and 28 can be rewritten as 4 times 7. Okay, they have to show that common 4, which they do, and then we can proceed to taking this 4 out the front. Okay, it says taking it out the front of a pair of brackets, and then I'm going to write what's left over in the set of brackets. So here, this 2x and this 7 is now what gets written in my set of brackets, okay, because I've already got the 4 out the front. Then I just need to get rid of this times sign and just write it like that. Question B, again, similar approach. I've got 15mn minus 20m. Highest common factor of the numbers is 5. Of the letters is m. So if I rewrite this 15mn into its expanded multiplication using the highest common factor of 5m, I write it as 5m times 3n. Okay? Then I rewrite this minus 20m as its expanded multiplication with the highest common factor of 5m multiplied by a negative 4. They share the 5m. Okay, we already know that from here in the thinking box. Then we take that 5m out the front and we write what's left over, which is the 3n and the minus 4. And we write that in the brackets, get rid of the multiplication sign, and write it like so.